Hello everyone. In this video, I'll be using Python Tutor to cover demo problems in order to understand the concept of for loops. Let's get started by initializing a variable MSG with a string value of ABC. The syntax for loop is for some variable in some other variable colon. The variable that comes after the n keyword is going to be MSG, which is the string sequence. Let's define the variable in between for and in as val here. Within the for loop body, I'm simply going to call the print function to display val. Let's step through this program from the beginning. Line 1 creates a global variable MSG which contains the string sequence ABC. When we execute first iteration of the for loop in line 3, that's going to create a brand new variable called val and initialize that with the very first character from the string sequence, which is the string A here. Hence the syntax for val in MSG colon. Then we are going to display val as A. The next iteration is going to update the val variable value as the character B. Then you're going to display B. The third iteration is going to update val as string C. Then you're going to display C. Then you'll go back and verify one more time that there are no more characters within the string sequence. Then your entire for loop execution here will be done. For loops are extremely powerful. Let me go through a couple of use case scenarios here. Let's say that we want to create a copy of this string into a different variable. I'm going to initialize that variable as copy underscore MSG and assign it to an empty string value. Within the for loop body, I'm simply going to say copy underscore MSG equal to copy underscore MSG plus val. Let's step through this program from the beginning. Initially, copy underscore MSG is just an empty string. During iteration 1, your val contains the string A. Then you're saying copy underscore MSG plus val here. So you're going to concatenate empty string with A, which is going to produce a string A. Then you're assigning the concatenation result back into copy underscore MSG variable. So that's going to update copy underscore MSG as A. During the next iteration, val becomes B. Since you're concatenating val with copy underscore MSG's existing value, you're going to update copy underscore MSG as AB concatenated string. And during the third iteration, you're going to concatenate the val string of C with the copy underscore MSG value of string AB. And that's going to create a copy of the string for you. Let's say that I change the requirement here slightly and I want to create a reverse copy of the string. I can do that by making a very simple change. I can just move the val concatenation to before copy underscore MSG. Let's step through a few iterations here. Initially, copy underscore MSG is just an empty string. Iteration 1 is going to concatenate val with copy underscore MSG. A plus an empty string is going to just give you the string A, which is going to go into the variable copy underscore MSG here. Iteration number 2 changes the val variable as string B. Then you're saying val plus copy underscore message. Val contains the string B. Copy underscore MSG contains the string A. So you're going to concatenate B with A. That's going to produce the concatenated string BA. If you keep continuing this, you're going to end up concatenating C in front of the string BA, and you'll effectively end up reversing that particular original string here. Let me switch over to the slide deck, and we are going to talk about a specific design pattern for loops. Just like while loops, for loops are used for searching for some value in a given data set. Let's go back to our table example that we covered as part of the while loop lecture, where we had a United States state-wise table where the columns are details like population and area. Let's say that we want to find the best population among all the states as the highest possible population. We want to find both the highest population value and the corresponding state which has that high value. One of the key things with respect to this design pattern is that often people don't know what initial value to start with. So they'll be using none as the initial value. We need to define two variables to keep track of the best population and the state corresponding to the best population over here. Let's assume that we have API functions for getting each row via the get underscore rows function, and get underscore population function is going to return the current rows population. Similarly, get underscore state function is going to return the current row state. What we want to do inside the for loop is that for every iteration, we want to extract the population and the state and compare those against the previously known best values, correct? Your if condition is often going to have such a form where you have parts of the if condition separated by or. The first part is always going to be best underscore that particular value equal to none or some other search condition. Why do you need the first part over here? That's because in Python you cannot compare none value with some other data type. So if your previously known best is initialized to none, you need to make sure that in iteration number 1, you're populating the previously known best value with that particular current iteration values. So the only time when best underscore pop variable will be none for this particular for loop will be for iteration 1, because you're going to update the population and state values after iteration 1. Every other iteration that other than iteration 1 will go through the search condition part of your if here. That's because your if first part here evaluates to true or something is always going to evaluate that something to determine your condition's outcome here. What do we want to include in the search condition for this particular example? We want to check the current iteration population against the previously known best population by saying that if population is greater than previously known best population, then we want to update the best population with the current iteration population and the corresponding state with the current iteration state. Please make sure to understand this design pattern example really well. You're going to need this a lot for project P5. Let me talk briefly about the range built-in function call. Here we have an example where we initialize the variable MSG to the string of 0, 1, 2, 3, 4. The for loop is saying for item in MSG colon. So you're going to extract every character. Then you're displaying item into 3, which will simply replicate each of those characters 3 times, correct? What if I wanted my for loop to iterate over the integers 0 to 4, which represent the index positions, rather than iterate over each of the characters within a particular sequence? You can achieve that by using the range built-in function call. The range built-in function call takes at the minimum one argument. That argument is going to determine the set of numbers that you generate as part of your sequence. So your range built-in function call is going to generate the values from 0 up until that particular argument value minus 1. So this particular for loop is going to run for the values of 0, 1, 2, etc. up to n minus 1. Then you can use those returned values into your for loop body, and the output of the program is now going to change as 0, 3, 6, 9 and 12, correct? That's because item contains a integer value, unlike the previous version of the for loop. I'll wrap up today's lecture here. I would encourage you to go and check out the range demo example that I have posted as part of today's lecture. I won't have time to cover that.